Good day, ladies and gentlemen, and we are discussing the mole, and let us continue with that discussion. Consider a compound containing 32.28% sodium, 22.65% sulfur, and 44.99% oxygen. What is the empirical formula for this compound? Yikes, we have a new concept, right? Empirical formula. So let us go back to our notes. We have this beautiful concept map of the mole. We talked about the definition here. We talked about conversions. And last time we started talking about calculations. And one calculation we talked about was the percentage composition. Now, empirical formula is another one of these calculations. So let us go over here and talk about empirical formula. Empirical formula. Good. So what is an empirical formula? That's right. We want to start with our definition. What's my definition? Now, this is a very valuable definition because if you understand the definition of empirical formula, you really don't need to memorize a process. You just always answer the definition. Go back to the definition. So here it is. An empirical formula is what? It is a formula for a compound showing the smallest whole number mole ratio of atoms in compound. Okay, now, what's the real important stuff here? Here, these four words. Smallest whole number mole ratio. That means we want to figure out what my atoms are in the compound, and then our elements in the compound, and then establish what? A ratio? What kind of ratio? A mole ratio. This has to be a whole number, not a decimal, and it must be smallest. Okay, good. So that is our definition. From there, we can come up then with a process. Zoink. Let's figure out a process for solving empirical formula question. So here's my process. Here's the way we're going to solve these. Number one, last time we assumed what? We assumed 1 mole. In this case, we are going to assume, hold on. I have to back up because there's really two types of problems. There is a problem where you are given percentages and a problem where you are given mass. Okay, let's talk about solving the process for a problem where they give you a percentage. All right, so sorry about that. Here we go. Number one, we want to assume you have 100 grams of compound. Last time we assumed 1 mole when we were doing percentage comp. In this case, we're going to assume 100 grams. Okay. Once I do that, I'm going to calculate grams of each component. That's easy. How? We're going to take 100 grams times the percent, right? Good. 3. Once I have the grams of each component, I want moles of each component. And how am I going to do that? I'm going to take the grams of my component and divide by what? The molar mass of the component. Cool. That's easy. We're great at that. Then what do I do? Okay, I want to set up ratios. Set up ratios of what? Of moles, right? Now, what am I going to do? I have these moles of components, and I'm going to use the smallest mole component as the denominator. And then I'm going to put other mole component in numerator. Got it? So I'm going to set up a ratio. It's going to be something like this. Maybe it's oxygen over hydrogen. And I'm going to say it's going to be moles of oxygen over moles of hydrogen if hydrogen is the smallest, smaller than oxygen, okay? That's just an example. It may be the other way around. Then what do I want to do? Well, if my ratio, I'm actually then going to divide, actually divide this, divide ratio, and then your answer will be some number over 1. Got it? And it could be 3, it could be 2, it could be 1.75, but you're going to get some number over 1. And if this number over 1 is whole, then hey, we're essentially done. Then this number is the number in formula for component. Got it? So let's say this is moles of oxygen per mole of hydrogen. Well, this would be what? 5 or something to 1, so it would be O5H1. Got it? You'll see it when I actually do the example. This is a little confusing. Good. Now, what if not a whole number? Oops, we have to do things. Here's what I recommend to do. Start, we want to multiply by 2 over 2, and then 3 over 3, and then 4 over 4 until you get whole number ratio. And what do I mean by that? Let's say that this step right here, when you divide, you get 1.5 to 1. Well, is that a whole number ratio? No. So what do? I'm going to multiply both the top and bottom by 2. And when I do that, what do I get? I get 3.0 over 2. Now, is that a whole number? Yes. So if this were, like I said, moles of oxygen per moles of hydrogen, then in my formula it would be what? OH, how many molecules of O do I have, or moles? 3. How many moles of H do I have? 2. So it'd be a 3:2 ratio. Got it? What if I had a 1.33 to 1? Well, I'd multiply it by 2 over 2, and what do I get? Well, I get 2.67 over 2. Is that a whole number? No. So I'd have to go 1.33 over 1, not by 2 over 2, but by what? 3 over 3. Multiply it by 3 over 3. What do I get? 4.0 over 3. Is that a whole number? Yes. And in that case, it would be what? 04 H3, assuming this is moles of O to moles of H. And that all depends, once again, on the actual problem. Don't get hung up on the moles of O or H. Those atoms can change depending on the formula, right? So that's what I mean. Now, here's the thing to be careful about. Rounding. Be careful of rounding. If you have 1.1 to 1.9 to 1, yeah, that's close enough to say that's 2 to 1. But don't round anything that's like 1.75 to 1. No, that's not. You can't round that. Don't round 1.3 to 1. Don't round 1.5 to 1. Don't round any of these. So you need to be somewhere in the range of maybe 1.8, 1.85 maybe is okay to round. 1.1, you can round these guys, but be careful about rounding those. Rounding can get you into trouble. All right, any questions? Well, let's give this a shot. That is the process. Aha, compound containing, what's the first thing I want to do? I want to assume that I have, 100.0 grams of stuff. Well, then, how many grams of sodium do I have? Well, I have what? 32.28% times 100 grams, so that would be what? 32.28 grams of sodium. How many grams of sulfur do I have? Well, I'd have 22.65% times 100, so 22.65 grams of sulfur. And how many grams of oxygen? Well, grams of oxygen is equal to what? 44.99 times 100, so I have 44.99 grams of oxygen. Next step, I want to convert moles. So I need moles of sodium, I need moles of sulfur, and I need moles of oxygen. So how do I do that? 32.28 grams times what? Where's my molar mass? Molar mass of sodium is 22.99. So 1 mole per 22.99 grams of sodium. Sulfur is equal to what? 22.65 grams times 1 mole of sulfur per what? 32.07. Here's sulfur. 32.07 we're going to go with. 32.07 grams of sulfur. And then oxygen, moles of oxygen, 44.99 grams of oxygen times 1 mole of oxygen per what? 16.00 grams. Got it. Let's do the numbers. 32.28 divided by 22.99. And what do I get? I get 1.4040 moles of sodium. I'm going to carry that guy through. Okay, 22.65 divided by 32.07. And what do I get? 0.7062. 626, sorry about that, 626 moles of sulfur, and 44.99 divided by, 44.99 divided by 16, and what do I get? 2.8118 moles of oxygen. Now, what do? Well, if you go back to our process, what is it that we want to do? We want to we got moles of each component. We want to set up ratios. What do we put in the denominator? We put the smallest amount of moles in the denominator. Okay, so here we go. What's my smallest amount of moles? Well, I have 1.4 sodium, 0.7. Okay, this is my smallest amount, right? Now, how many ratios do I need to set up? Well, I'm going to need a ratio between sodium and sulfur, and then I'm going to need a ratio between what? Oxygen and sulfur. So I have moles of sodium per moles of sulfur, moles of oxygen per mole of sulfur. Now, why do I have sulfur twice? Because it is the smallest one. It is the denominator at each. Good. So how many moles of sodium do I have? I have 1.4040 moles of sodium over what? 0.70626 moles of sulfur. So when I do that, I take 1.4040 divided by 0.70626, and what do I get? I get 1.9879 moles of sodium, but that is to what? That is per 1 mole of sulfur. When I do this division, that means I'm making it per 1 mole of sulfur. Cool. Now what about here? I have moles of oxygen. Where are my moles of oxygen? 2.8118 moles of oxygen per what? Well, I have to use my sulfur again, 0.70626 moles of sulfur. Good. So 2.8118 divided by 0.7062. Yoink. And what do I get? 3.9815 moles of oxygen per 1 mole of sulfur. Good. Now, here's the question. Can I round this to 2 to 1? The answer is yes. So this is really what? 2 moles of sulfur, sodium per 1 mole of sulfur. Can I round this to 4 to 1? And the answer would be yes, that's close enough to 4. So this would be 4 moles of oxygen per 1 mole of sulfur. Good. So what is my formula? I have Na, I have S, and I have O. Now, how many S's do I have? What's my ratio? I have 1 S, and for every 1 S, how many oxygens do I have? I have 4. Good. For every 1 S, how many sodiums do I have? 2. So that would mean I have N2SO4. That is my empirical formula. Wonderful. You guys try this one and bring me back when you're ready. Well, what's the first thing we do? We're going to assume 100.0 grams of stuff. And if I assume that, that means I have 73.9 grams of mercury and 26.1 grams of chlorine. And I want then to get moles of mercury. And moles of mercury are 73.9 grams of mercury times 1 mole of mercury per what? Well, let's go to our periodic table. Where's mercury? 200.59. 200.59. Wow, 200.59 grams. Okay, and then we want moles of chlorine, which is 26.1 grams times 1 mole of chlorine per what? Let's go back to our periodic table. Where's chlorine? Here is chlorine, and it's what? 35.45. 35.45 grams. Cool. Good. Now, let's do the numbers. 73.9 divided by 200.59. Got it? Oops. Yep, I get 0.3684 moles of mercury. And what do I get here? 26.1 divided by 35.45. Cool. 0.73624 moles of chlorine. Now what do? Well, I want to set up my ratio. Which one goes into the denominator? Well, that's the smallest one. So I want to set up a ratio of moles of chlorine. It's the bigger one on top. Moles of mercury, that's the smaller one on the bottom. And what do I have? 0.73624 moles of chlorine over 0.3684 moles of mercury. Got it? Good. Let's do the numbers. Divide by 0.3684, and I get 1.998 moles of chlorine per 1 mole of mercury. Good. Is this close enough to round to 2? The answer is yes. So I can round that to 2 moles of chlorine to 1 mole of mercury. Now, why do I need to round that? Because I need to have a whole number, right? So that means my ratio is 2 to 1. I have Hg, I have Cl. For every 1 mole of Hg, I have 2 moles of mercury. And so, for every moles of mercury, I have 2 moles of chlorine. So that is my empirical formula. Got it? I'll tell you what, let's call timeout right here. Next time, we'll do a couple complicated versions of empirical formula. See you next time.